Okay, guys, let's go. Okay, so last year, you guys, stop talking. Okay, so last year we did, you guys did a ton of work with function composition, right? So function composition is when I would give you two functions, or Christensen, or whoever you had, would give you two functions like maybe x squared and g of x is cosine of x, and they'd ask you to compose the functions, right? So I take that and I plug it in for x. You guys did a bunch of that last year, right? Okay, so what we're going to start with today is I'm going to ask you to do the opposite. I'm going to give you the composed function, and you need to deconstruct it. And you need to tell me what was f and what was g. Okay? So we're going to do a few together. So let's say I gave you f of g of x is the square root of e to the x. Great. Tell me, what's the answer?
G of x equals e of x and
E to the x.
yeah, e to the x, and then f of x equals the square root of x.
Perfect. You see that idea? So I'm giving you the composed function, and you're going to deconstruct it for me. Good? Ready for some, can I make it a little trickier?
Yes.
Okay. So h of x is my composed function, and 1 over cosine x is my function.
Wait, what's the composed one?
1 over cosine x is my composed function.
But not
So what was f and what was g?
F is 1 over x.
Talk with your groups. Let's make sure everyone can do it. Talk with your groups.
Yeah, cosine of x. Yeah. So g of x equals cosine of x. Yeah, h.
Well, you can think of it as its own function, but we haven't learned a derivative rule for secant yet, so we're not going to worry about it. It is, yeah. But secant x then is one single function, and then we're trying to split it up into two separate composed functions, and I know their derivative rules.
So
Maybe, but there's always an easiest one.
h of x just means f of g of x.
That's my composed function.
Okay.
Okay, so that's my f of g of x. So in this case, f of x, 1 over x, g of x, cosine x. Okay, one more. H of x is try that one with your neighbors. H of x is my composed function. Careful on this one. Have a question?
Just make every f of x x, and then every g of x the h of x.
Sure, but then how does that help me? Because then I still have to decompose the g of x every single time. So I'm creating 3 functions out of something that's really only 2 functions. Okay, I'm going to give you a hint on this one. Okay, a lot of people have a hard time with this one because they forget that this is the shortcut way of writing that. So f of x is x squared, and g of x is sine x. Did anybody get that before I gave you the hint?
I was.
Yeah, good job.
I was
Good.
thinking that, but then I was like, no, there's no way it's like this.
Okay, how you guys doing, okay? Now we know how to deconstruct a composed function. Sounds fancy, huh?
Yeah.
Okay, so now what we're gonna do is I'm gonna prove to you how to, or we're gonna develop together the rule for finding the derivative of composed functions. It's called the chain rule, okay? So that's what we're gonna do now that we know how to decompose functions. Okay. So we're going to say let h of x equal, whoa, what is that? Division line? It might help today to follow along with how I write the colors. Because we're going to do some pretty abstract thinking here today. And it's amazing how when I just change the color of part of it, it makes sense. Isn't that a miracle? Yeah, it's weird, right? I remember the first year I taught this, it didn't go well. And then the second year I was like, maybe I'll try and split it up by color with the composed functions, and then it went great. And I was like, whoa, math. Oh, that's the worst H ever. Because you guys get that these H's are totally different, yeah? So I'll use capital H and lowercase h. They have no relation to each other at all, right? Okay. Okay. You guys good? Oh, you gotta color code it. I just made a big spiel about that, huh? Didn't give you time to do it. Typical Summers behavior. You guys think I go fast today? You should have seen me get through our last lesson in 43 minutes on my 8A class yesterday. I got through it. I went fast. Huh? You had a friend in there, they said that? Oh, I went fast. I warned them all at the beginning. I'm going to get through it. You? I don't know, but I'm going to get through it. Okay, ready? Okay, so here's the problem. So, okay, let's just refer back a little bit to our synapse discussion. You're like, what is that? But hopefully you'll remember. The more I have it, that's a joke you'll get in a second. So a synapse in your brain, right? Think of it like a hiking trail. The first time you try and do something in math or in English or in gym or something, right? It's like you're on a hiking trail for the first time. You have your machete and you've got to hack your way through. And it's not easy and you don't always know where it's going to go, right? But then the more you travel that path, right, the easier it is to walk on the path. Does that make sense? That's how our brain works. So the more of these limit definitions you do, and don't worry, we've got a lot more to do, right? When we're proving things, some of the strategies I use, at first today you're gonna be like, I would never have thought of that. I'm like, yeah, I know, I get it, right? But the more of them you do, the more likely it is you'll think of it, okay? Now, all of the limit definitions that we've done so far, I've been able to do some sort of algebra in here, right? But the problem on this one is there's nothing I can do. There's not a k I can undistribute, okay? There's not a, I can't distribute in here because this is function composition, right? Those are functions that are attached that way, okay? I don't know what type of functions f or g are. There's nothing I can do, right? So that's the hint to me. If there's no algebra I can do, then I probably need to put something new in there, okay? Now, I'm going to show you what I'm going to choose to do. And I'll explain why I did that in a second. Okay? is what I just multiplied by changing the value of the fraction at all? No, why not?
Because they simplify to be 1 over 1.
You got it. It simplifies. It's like timesing by 1. It doesn't change anything, right? If I do something to the top and then I do it to the bottom, I'm not changing anything because it's like I'm multiplying by 1. Perfect. Okay? Now again, the hint that I needed to put something new to develop this rule in there was that there was nothing I could do to that. Okay? So far okay? Okay. Multiplication is commutative. Somebody raise your hand and tell me what that means. Okay, here. Doesn't matter the order that I multiply stuff in. So I can swap things. Okay, so that's what I'm going to do next, is I'm going to swap denominators. Because I feel like it. Ugh. This is not the one I wanted to do. Oh well, we're already here. We're already here. I wanted to do the third one. I thought it would make more sense.
The A to X.
Yeah. It's alright, we're already here. It's already happening. It's fine. I can show you the A to the X one real quick in a second if this doesn't, if you don't feel like this makes sense to you.
Wait, won't those just become X?
Hmm?
Those just become
Does the what disappear?
Can we factor out that F?
No, because that's like we don't know what type of function f is. What if f is a sign? What if it's an ln? You can't factor out an operation like that. Only if f was just a number. Okay, you guys are gonna hate me, but I think we need to switch this up a little bit. I'm over it.
No.
I was writing it. I was doing a pencil.
I was using pens.
This is gonna make a lot more sense to you, I promise. Just rewrite it, it's fine. It's gonna make more sense to you if you do it like, if we do this one. It's okay, I'll give you time to catch up. It'll be worth it in the long run.
That's probably good.
I really think this one will just make more sense to you.
Just left mine. I was like, bruh. This time just.
You'll thank me, I promise. This one is, it's gonna, as soon as you change it, it'll make more sense, I promise. Give you time. I promise you'll appreciate the change.
Oh no.
Sorry.
See, that's why you use erasable pens. I have erasable pens, I'm just not using them. Why not? I don't know. No one's been smart. You save my life every day.
Okay, I'm gonna give you like a minute or so with your neighbors to get that fixed, and then I just want you to process it. Think about what's going on. Think about our limit definitions. I really think making that change is gonna help this come together better for you guys.
Do you see my hand over here?
Okay, you guys are you processing? You guys, focus please. Okay, process.
I did. Okay, start. What do you notice? What things are happening? Oh, the bottom is just whatever's.
Chatting with each other.
Just whatever, like the denominator is always, right now it's just what's in the name of. You see, it's like that's true, you're it's just.
Oh, never mind. Is that what helped you to feel about?
Which gave us like that.
Well, here's the thing. This is inside of that.
Okay, another 30 seconds. Please make sure you're focusing on this.
Oh, yeah. Yes, I do. You know how long I've been waiting to have one of those again?
The scissor,
All right, what are you thinking?
I see the pattern, but I don't know how it would be relevant.
Okay. What are you thinking, you guys? Are you focusing on this?
Yep.
The more of these we do, the less I'm going to be there to guide you. Yeah. What do you see? What do you see? Anyone see anything?
Yes.
What?
The denominator is like what's in the, it's like the, of it, I don't.
The denominator is like what's in the thing?
It's what's in like the function above.
Okay.
It's like inside the
That's
parentheses.
absolutely important. What do you think? Didn't we prove something like the second half? Kinda.
Can't you just cancel out the g of x minus g of a, and g of x minus g of a, so that it's just f of g of x minus f of g of a over.
But that's just.
You could, but the problem is that's back to our original we started with that we're trying to change.
I was like, yeah, we could do that, but that's the whole.
Because that, we knew we had to multiply something else because there's no algebra I could do in here, so I knew I had to bring something new in. Why I chose to do this will become clear as soon as we figure out how it simplifies. It all has to do with what Chase brings up, the fact that I wanted this composition, I needed this as my denominator here to go with this composition so that I could do something. I just don't want to tell you what that thing is I can do now because that gives away, and I don't want to take your learning moment.
So can we keep thinking?
If you actually think, I don't know if you actually think, yeah. But come on, so start with the second half. If you can't figure out the first half, then start with the second half. What is that?
Where g of x equals g of x. I'd say on the second g of x equals x. On the second. Like pull out g. Couldn't you do g of x minus a? Couldn't you do g of x minus a?
Okay, what's this? What's this? As a goes to x, what's this? No? No? It's one of the definitions, so what is it?
G prime.
It's g prime. Of what?
X.
X.
I agree.
That's what I was saying, is we just.
That's one of the definitions. Right? What else, you guys? Come on, we gotta get through this.
Oh, is there a way to get rid of that? Oh, that is. So wouldn't it just
Yeah,
be?
Isn't it the same?
What do you mean, is it the same?
Well, because.
They're both like a step up, so it's just like a different way of writing the second one. Sorry.
So it's a different way of writing the second, there's not enough specifics in that, I don't understand. Yeah, no, someone else. You want more time now to talk and think about it with your groups? We have 30 more seconds.
The g of x is like the same.
Come on guys, you're there.
Yeah. Yeah. Because it's like on that side, they're all one g of x. But then on the other side, they're just.
There's a reason I did the color coding. Okay, go. Hold on, quiet, I can't hear ya.
I don't know if this would simplify it at all, but since like the g of x and the g of a are basically just like x of a, then like part of the function of f, so it would just be f prime of g of x.
Yeah,
Yep.
that's what I was saying.
This is a limit definition for f with the input of g instead of the input of x. Right? This is the chain rule.
Oh.
Right? Think of the G's like X's and A's. Isn't that our third definition of a derivative for f prime? But our input is G instead of X. Perfect. Okay? That's our chain rule. We're going to practice this a bunch today. Okay? So let's start with one of the ones we did at the beginning of class. Did okay, what did I do? Sine squared of X? Wasn't that one of the ones I did? So we said f of X was X squared and G of X was sine of X, right?
Yes.
So, on this one, if I wanted h prime of x, I would do f prime of g times g prime. And I make it look a little nicer if I want to. If you don't, I don't care. So f prime, right, of g times g prime.
Whoa, 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 whoa.
Sheesh, okay. That's hard.
Oh, thanks. Questions? Okay, we're gonna do more.
Hold on, can you give me?
Oh yeah.
Gotta write all that down.
Okay, next one. I want to do another example from ones we did earlier where you already had deconstructed the function. H of x was, did we do square root of e to the x? Right?
So it's
Remember my f of x
square root of x,
was the square root of x, and my g of x,
e to the x.
my inside function was e to the x. So h prime of x is f prime of g
Whole time by,
times g prime
which is, that's g prime.
And on an FRQ AP test, I actually even prefer you leave stuff like this. That's probably because where you usually do your mistakes is in the like arithmetic, not necessarily in the calculus, right? But on a multiple choice, they'd probably combine it more than that. So that's what I'll show you on the board. So I always think about it like, okay, once I set up my chain rule, f prime of g times g prime, then I just try and maybe make it look a little nicer. So on this one, I do 1/2 e to the negative 1/2 x, e to the x. Same base, right? So I can add their exponents.
would they like us to keep it in the half, the 1/2 x, or the?
They don't care how you keep it, you just have to identify it. They might put their answer like this, they might put their answer like this. There's, like, when you're at this level in math, nobody cares how it looks. That's why we don't care about if you rationalize the denominator. We don't care if it's fractional exponents or radical exponents. We just want right answers, okay? So your job is more to be able to identify equivalent answers.
Yeah.
Do you guys want one more together, or do you think you're ready to try a couple chain rules on your own?
Together.
One more together? Okay, let's do one more together. What's the third one I gave you at the beginning of class?
1 over cosine of x.
Okay. So on that one, my f of x was 1 over x, right?
Yeah.
And my g of x then is cosine of x. Okay. So in order to find this derivative, I want to rewrite it for my power rule, right? Okay. So f prime is negative 1x, no, not x. To the negative 2, so that's my f prime, right? Of g
Okay.
and then times g prime of x. So let that sink in, and then I'll go through and make it look a little nicer. Good? Okay, then you can leave it like that, or if you want to check answers in the back of the book, or if it's on a multiple choice portion of an AP test or something, then I'd probably cancel out the negative sign and move that down. So that's how I make it look a little nicer on this one. Start writing down these practice problems I'm going to have you do. Okay, I'm going to give you guys about 10, 12 minutes with your neighbors to try these. We'll go over them and then we'll do our last thing for today.
This is just
Oh, yeah, you're right.
It's like, that's.
I did the same thing. Yeah, I was like,
Wait, so what you do is write. So back of this image, 1 over 2. What's even? We don't know. And equals.
Oh, there's 7.
wait, like, so, wait, hear me out. 1 times 2 is 4 to the x. 6 to the x. 3 to the x, 6 to the x, right?
We're just finding the prime of all of them.
Yeah, so you
Oh, yeah, I was thinking that just GMX is square root of x.
GMX is the square root of x.
Because f of x is the axis. Okay, so f of x,
GMX
GMX
is
is
reflected.
Oh, no, we're just doing this.
Okay, so yeah, so.
Hold on, I'll go
That's
back.
not what I got. Well, then we have to find the prime.
Is that what I got? Did I still got it? So I have had all these to the negative 2.
Oh, yeah, so
That's how I do use x minus.
how you got it?
That works though, right? That's what I
That's it.
Oh, wait.
Only thing that changes is well, that's h of x. Yeah, h of x is the same thing as prime.
Yeah.
That's what we're trying to find for the
Wow.
f prime.
Number 2. Out of 7.
This is pretty much the same thing with x. We're just trying to find the primes. So you just need to just really focus on this. The only thing you can change is this side. So it would be basically f root GMX. So it's going to be
So if it's 5x half, it's 2 because there should be
Oh my
Yeah,
know the
Do you
garbage.
guys know what that
The second one, f prime of x would be negative 5x equals negative 2. Get rid of the fraction and make it all next to each other. And put a negative exponent in there.
Wait, we were.
So like you have to find the percentage.
This first thing. This first thing.
Okay, so this is what you got.
Put the x in one minus negative.
That is what you got.
Oh, there's no square root.
Because it's
The square root nine.
so negative. So
Wait, what's the derivative of x?
x is.
That what you got? Yes.
Why do you want us to Mike and right? I could be completely
No,
wrong.
I'm just saying if two people get the same answer,
I go same. Like,
My son is like a super right now. I'm like, what?
the crowd have number two. Like,
Oh, because that one is a constant.
Ah, coefficient.
Yes, that would be
There's gotta be an efficient, really easy.
Dude, I always fall for those.
Yeah, channel.
we can rearrange this to four.
wait, L of 3 is L
Because it's just log base e, which e is a constant of 3, so it's some random.
Grace, you okay? Okay.
More.
What's your F? Square root of x. That's the outside function.
Sweet.
3dx plugged into the square root, right? So your g of x should be 3dx. That make sense? And the next thing you want to do is change the f of x to be x to the 1/2, so you can use the power rule.
Oh god, sorry. Wait, so you don't need this symbol, like you can leave it.
Yeah, and I prefer that on a free response because where you make a mistake is probably going to be in the easy simplifying, right? I'm sure you guys are already starting to see that.
We just plug everything in, and we can just leave it like that.
Sure. But where you the only thing is if you're taking answers in the back of the book, they're going to simplify it some, and then if you are on a multiple choice, they're not going to leave their answers like that. So as long as you can start identifying equivalent answers, then that's all you need to do.
So number 3 check what you're
Wait, Miss Summers.
Hold on, let me finish getting my Facebook on.
I did minus it. Oh, L of 3 is also 3. Oh, it's coefficient.
Yeah, I just did.
I heard a Miss Summers wait.
Oh, yeah. Couldn't you just use like, while you're doing homework and stuff, just use a gravity calculator to graph like shapes and graph like what the
Yeah, that's a really clever idea. In fact, you could, there's non-calculator portions of the grade P test, but there's also a calculator multiple choice portion. That's something you could do on that portion too. I mean, those are just good ideas.
Let's do what?
Using your partner.
check, because you know how
stew. You just called me T, so you're a stew.
They should line up exactly each other.
No, that's Brian is way off, guys.
That way you don't have to simplify it.
So you're, no, because there should have been an L and a 3 somewhere in G. Because 3dx, it's derivative, that's an dx one, right? So the derivative of 3dx is 3dx
We're
times.
not on three, okay?
This is wrong.
I'm on.
Haven't I told you this?
It's just like, I don't think.
Yeah, okay, so the derivative of 3dx is 3dx times L and 3.
Yeah.
So you know there has to be L and 3 somewhere, right? So, you can't, what you were trying to do is do a power rule on G. Power rule doesn't work on G, because it's not called rule, it's a function. Right? So you do want to do the power rule on the x still in half here. Because 1 half minus 1 is negative 1 half, not negative 3 half minus 2.
Wait, no.
Does that make sense?
Yes.
Good?
To be honest,
You weren't here last time. I know. Have you watched the video yet? That's okay. That's okay. Okay, let's just make sure we're doing good on this first one. Times Ellen of Alien.
That's what I was like.
Oh, you're on number 7 already. I thought you were still first.
Well, I guess if you want to say this, no, but it's like that. In that scenario, you're not doing absolute times.
because you eat it in the number.
Yeah, I guess you could do it.
Yeah.
Just to say, yeah.
That scared me.
Yeah, that's right. That's right.
So then you would need 1 half minus 2x and then like squeeze.
Number 5, or whatever the little.
X to the power, so then you put the n in the front, so then that would be 1 half. X, and then it's 1 half minus 1 half. And then 1 half times. Over x. So then 1 half times 1 over x. 1 half over this wait, that's really bad.
As long as it's equivalent, it doesn't matter how you write it.
Oh, that's what I got.
Did you get negative 1 over to the x?
Oh, yeah, I guess you could write it that.
Flux against travel.
Yeah.
Already?
Let's go.
And then you would multiply by
I'll start with you.
Sounds to me like all 4 of you guys could go put an answer up on the board, huh? Yeah, thanks. I don't care which one. Good job. You're only the only group that's done by far, so.
Okay, I'm on that.
I'm on number 6 too.
Thanks. I don't care which ones you do. Go write them up.
No, just put the answer.
Well, you guys are done too? Great. When they're all done writing, the other ones left over, you two can do it. Yeah. Yeah.
Wait for number 5, you just get e to the negative x half minus 1.
Negative 1 over.
Yeah.
I'm gonna write some
Oh, yeah.
like all the answers.
I just like it better.
I really want her. Jesse's like, it's an answer that's it. It's a question.
K? Does that say K to the X? KX? Okay.
Yeah, KX. Do you want me to
Okay.
write down number 3, the long one?
Get it? Get it? Get it? Funny, funny. You chose to do number 3. Good job, Spencer. I like that.
I'll either do like really good or totally fail.
Oh, I'm sure it's gonna be good. It's a weird one. Good work.
Cooked. Can I do an answer now?
No, they're doing the other 2.
I didn't know what the numbers are.
Number 2 and number, what is it, 5 is still open? No, number, Igor, didn't you already do one? No?
I did number 5.
Oh, okay, yeah. I thought you were standing up waiting to still do one, and I was like, wait, did I count them?
Okay, yeah, that one's really good. But that is what I got.
Oh, thank you. I'm just stretching my old lady back. I need a chiropractor appointment. But I appreciate the attention paid. Okay, I want you guys to take a look. Take a look. What do you think?
I feel pretty good.
Take a look at all the answers. What do you think? You agree? Do I need to go over any of them? I just chose people. I didn't read what was on their paper, so I don't know if they're right. That's your job, not my job.
Did you guys get that for number 3?
Yeah, that's what I got, number 3.
Yeah,
Or
that's fine.
something equivalent,
I got
right?
that number 3. Or it could be pricing.
On number 6 though, it wouldn't be minus 4x, it'd be like multiplied by negative 4x. Wait,
Oh yeah, it looks like you.
wait, what? Yeah. Wait, what? Number 6.
Oh yeah, I have a way different
That
answer.
is not what I got for number 6.
Okay, let's look.
But other than that, everything else is the same.
So on this one, my f of x is e to x, my g of x is negative 4x, right? So f prime, oh, so this should be plugged into it.
Yeah.
And then times by g prime, so times negative 4.
Yeah, that's
That's what we got.
Okay, any other ones?
how much, look how much I did. Look how much work that was, like, really fast.
Any other ones? You guys getting the hang of it? Because I'm going to build on it next. Getting the hang of it?
Wait.
Questions, gentlemen?
For number 5, you could also write it as negative 1 over e to the x.
Sure. Questions? Oh, good. Let me take it up a notch, huh? Hey, get out your ultra lavas real quick, and then we got one more thing to talk about today. Get out your ultra lavas, please. We've got 2 rules to add to that today. Ah, your derivative rules table. I'm not going to rewrite everything in there.
Igor, you're a genius. Oh, it's. Oh, wait, I thought that was next one. Good job. Just. Genius is almost scary.
So those should be added on to the ones we added last time. So how many do you have as of right now? 1, 2, 3, 4, 5, 6, 7. So this should be your 8th and 9th.
Why do can X have to be so simple?
Huh?
Can X is so simple?
Yeah, I don't know.
Wait, this should be our 9th?
It should be your 8th and your 9th. Back to your notes once you get those 2 rows in your ultra lava. Is there an older sibling of yours, John, maybe? Do you have a John?
He's a younger sibling, just by a year.
Who's your older brother?
Isaac, his brother, he doesn't live anymore.
Isaac, okay.
He said that you probably wouldn't remember him. I don't know.
Because was he quiet as a mouse?
I don't know. I mean, I've never been in a class with him, but he's pretty chill.
If I did? Oh. Good one. You guys get me with that all the time. It's so funny. I have Max. Is Max his first name?
Yeah.
Oh, yeah, I get
That's
it.
his middle name.
Oh, yeah. Okay.
Well,
Okay, guys, last thing. Last thing. Okay? You guys stop talking. This is back to your notes. You guys got this down? Okay? Not on your ultra lava, back in your notes. Okay. So, you guys are now pros, right? At 2 function chain rules, right?
No.
But it actually, once you get the 2 function down, it's not that bad. Especially if you visualize it with my handy trick. Do you guys know what Russian nesting dolls are? Okay, so a Russian nesting doll, right, is like the ones that you crack them half open, and then the puzzle only works if all the smaller ones are inside the bigger ones in order, right? Okay, so there's a nice pattern with this. When I have more than one function, okay, so when I have 3 function chain rule, oh, wait a minute. That's not what I wanted. Okay, so hold on. Stay with me, you'll see it. Okay, so I take the derivative of my biggest function, okay? And then you're gonna take the smaller dolls, the smaller functions, and plug them into each other. Times g prime of x with all the smaller dolls plugged in. It's not too bad once you see the trick, right? Like even if I wanted,
Oh my goodness. Oh, I suppose that makes sense because.
Getting to stretch the lessons.
Yeah. I could agree. Well, there's colors to do this. Wait, what's the last letter you have?
I think I did A.
Guys, look at this, look at this, look at this.
So you can do it for forever.
Yep.
You wouldn't want to. It's gotta be like a shortcut or something.
This is the shortcut.
No. There's gotta be a shortcut. There's gotta be a shortcut to this.
Yeah, the chain rule is the shortcut. But you guys, once you see the pattern, yeah, it might be annoying. They're not going to simplify very pretty, of course. But setting it up is not too bad once the pattern clicks. And again, if you can visualize the original chain rule and then Russian nesting dolls, it helps. So you take your biggest function, find its derivative, then plug in all the smaller dolls, right? Then you find the next biggest function, find its derivative, plug in all the smaller dolls, right? So notice how it's the biggest, then the middle, right? And it goes down descending order. Why is there nothing plugged into this one? Because that's the smallest doll on that one. You see the pattern? Okay. We're going to do one quick example of this 3 function chain rule and then we're done for today. Okay, your homework tonight is from the book. It's all chain rule practice. You don't need to do the derivative definitions for any of them. Just do the chain rule, okay? But I'm going to give you another 20 seconds to catch up with this, and then we're going to do 1 3-function chain rule together, okay? Okay. There it is.
Oh, I think I got it. I think I know.
All ready? You can just spout it off.
Yeah, f of x. Oh, I was sorry, just the f of x part.
Oh, it's like 3.
No, not your business.
There's not a lot this year that I can make more like structured and patterned like this. Most everything's pretty conceptual, right? So try and make this very like a pattern. Okay? Take your biggest function, take its derivative, plug in all the smaller dolls one inside of each other like a composition. Russian nesting doll.
Rule a lot.
We will use chain rule every single day the entire rest of the year.
The
I don't know if it'll be a 3-function one, but we will use chain rule every day the rest of the year. Except for maybe next time when we learn, no, we'll use it because I'm going to use it to prove the inverse property. But then we're going to do product and quotient. Okay, you guys are doing good. The homework's there on the board, or I'm going to text it out in about 10 minutes. So, good work. Thank you.